Welcome to section 1.4. In this section we're going to be discussing the major topic is order of operations. In order to talk about order of operations, we first have to talk about exponents. And then we're going to talk about different ways that order of operations is used. We're going to see it used when we talk about using variable expressions, when we talk about equations. So we're going to kind of tie in all these different ways that you will see order of operations. All right, the first objective in this section is to define and use exponents, and then talk about how we do order of operations. So exponential notation is the shorthand way that we can write repeated multiplication. So instead of writing 2 times 2 times 2 times 2 times 2, that can be written as 2 raised to the 5th power. 2 is the base. That's the number that we're multiplying over and over again. And 5 is the exponent, and that is the number of times that we are multiplying the base together. So there are 5 2's all multiplied together. So definitely using exponential notation is going to be really helpful. All right, so you're going to start off with some questions that are very, very basic. So when you are doing these, don't just type it in your calculator and write down the answer. That's not going to help you learn about what these words mean and how they operate. So think to yourself, what is 4 raised to the 2nd power? Okay, that means we have a factor of 4 that is being multiplied, 2 of them being multiplied together. So 4 squared, or 4 raised to the 2nd power, is the same as 4 times 4. And hopefully everybody knows that 4 times 4 is 16. So that's more of what I want to see. I want to see that you're using the definition. What does 4 to the 2nd power mean? So make sure you write that out. As these problems get more and more complicated, you will not have to do that. But when you first start, make sure that you really understand what those powers mean. All right, b2 to the 2nd power, that would be 2 times 2, which would be 4. 3 to the 4th power would be 3 times 3 times 3 times 3. Right, and you can do that. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So you just multiply those one at a time. All right, 9 to the 1st power means that your base is 9 and you only have one of them there. It's only one factor of 9. So that's your answer. You're already done. This is why we don't write first powers in my math lab or in general. My math lab will mark it wrong if you put a first power, because 9 to the 1st power is just 9. So you should never ever write a first power on anything. Even if your base is a fraction like it is in example E, you're going to do the same thing. Okay, your base is 2/5. So this is going to be 2/5 times 2/5 times 2/5. Right, just like if the base was a whole number. Okay, same thing. And we know from section 1.3 that when we're multiplying fractions, we should first see if we can simplify, which we cannot because we have just factors of 2 in our numerator, and we have just factors of 5 in our denominator. So there's nothing that will divide out. So we're just going to multiply our numerators. 2 times 2 times 2 is 8. And then 5 times 5 times 5 is 125. So there is my final answer, 8 over 125. If you have a decimal, I find that most students don't know how to multiply decimals. So I think the best thing to do is to change these to fractions and then do the problem. Fractions are a bit easier with this. So if you look, 8/10 raised to the 2nd power, even just by saying it correctly, 8/10 to the 2nd power. Those two are exactly the same. I would leave the denominator as 10. I wouldn't simplify 4/10. If you have a decimal in the original problem, you can write your final answer as a decimal. And decimals love 10. So if you have a 10 in your denominator, leave it. All right, so this is 8/10 squared, which means this is 8/10 times 8/10. And hopefully, again, don't simplify this one, because remember, decimals love 10s. So 8 times 8 is 64, and 10 times 10 is 100. So that is 64 hundredths. And if you write 64 hundredths as a decimal, that would be my final answer, 64 hundredths. Really important in math that anytime you start with whole numbers or fractions, that your final answer should be a whole number or a fraction. If you start with a decimal, you can have a decimal as your final answer. But if you start with whole numbers or fractions, then you should definitely not have a decimal answer. unless, of course, the problem specifically says to write your answer as a decimal. Otherwise, we're going to expect whole numbers or fractions. Order of operations. Okay, so now we can actually use these exponents to talk about order of operations. Most people were taught order of operations incorrectly. I know I was. In the 7th grade, I was not taught this. So I'm sharing this with you because maybe you didn't learn it the right way either. So when you are doing an order of operations, the first step you should do is to perform any calculations inside parentheses. Okay, so that means they could be round parentheses, they could be square brackets, anything like that. Absolute values, those also count as parentheses. So any kind of grouping symbols. So you might want to just take out that word parentheses and put the word grouping symbols, because there's lots of different things that could be grouping symbols. The next step after you've done your grouping symbols is to apply any exponents. Okay, and you will find later on, especially when you get into 1033 and 1105, all your intermediate algebra, your college algebra, that exponents could also mean roots or radicals. So make sure that you keep an open mind when it comes to exponents, because that will be expanded upon as you go through your other classes. After you've done all of your exponents at that point, then step number 3 is to perform any multiplications and divisions, whichever you see working from left to right. So I was taught to do multiplication first and then division, which is incorrect. Okay, you want to do any multiplications or divisions. These have the same hierarchy. Multiplication is not more important than division. They are equally important. So you do whatever you see from left to right. Once you've gotten rid of all the multiplications and divisions, then the last thing you're going to do, step 4, is to do any additions or subtractions. Okay, and do those from left to right, whatever you see first. And then a little side note, if you do have a fraction bar in the problem, simplify your numerator and your denominator as completely separate problems, and then the last thing you should do is the division of that fraction. All right, so that is how you do order of operations. So we're just going to go through a bunch of examples, and then I'm going to show you how to use order of operations in different situations. All right, so here's our first example. 6 divided by 3 plus 5 squared. So I'm just going to go down the list. Step number 1 was to do grouping symbols. In this problem, we have no grouping symbols, so we can skip step number 1. Step number 2, do we have any exponents? And we do. We've got this 5 squared right here. So that's the thing I'm going to do next. So I'm going to rewrite the problem. And 5 squared I know is 25, right? 5 times 5 is 25. Okay, so I've done all the exponents. Then step number 3 says to do any division or multiplication from left to right. So I'm going to start at the left, and the first thing I see is a division problem. So that's what I'm going to do first. 6 divided by 3 is 2. And then again, I'm going to rewrite the problem. So every time you do a step, you should be rewriting the problem to make sure that you're showing all your work. All right, and as you can see, the only operator we have left is an addition sign. So 2 plus 25 is 27. So that is my final answer. And notice I've shown all my work. Everything's nicely labeled and right underneath, so you can see the step that occurred before. All right, next example. First thing I see is that this has a fraction bar. So I'm going to look at my numerator and my denominator as completely different problems and do them separately. So you can decide whichever one you would like to do first. I'm going to do the denominator first on this one. 3 squared. 3 squared I know is 9. So yay, I'm done with the denominator. Woohoo! All right, then I'm going to go up to my numerator. Okay, in my numerator, I do not have any grouping symbols. I don't have any exponents. So I'm going to do multiplication or division from left to right. And the first division or multiplication I see is this right here, 9 divided by 3. Okay, 9 divided by 3 is 3. So I'm going to rewrite that problem. That is now 6 plus 3. And 6 plus 3 we know is 9. So simplifying my numerator and denominator, I get a 9 in both. And the last thing you should do is that division. What is 9 divided by 9? That is 1. So there's my final answer of 1. It's a lot of work just to get the number 1. All right, here's another example that's also a fraction, but this time it's a bit more complicated. So again, treat that numerator and that denominator as completely different problems. So I'm going to start with the denominator because 8 minus 5 is 3. There's only one thing to do. And I'm going to put a couple of extra 3's here, just because I might have some, looks like that numerator might be a bit more complicated than I'd wanted. Okay, so step number 1, start with your grouping symbols. We have some absolute values, okay, so we have to do this first. All right, First of all, inside the grouping symbols, we have 7 minus 4, which is 3. So this is the absolute value of 3. And hopefully everybody knows what the absolute value of 3 is, 3. So I can rewrite this, eliminating those grouping symbols as 1 plus 3 squared. All right, so I have eliminated my grouping symbols. Next, I'm going to go to my exponents. 3 squared is 9. So this is 1 plus 3 plus 9. Again, you need to do that exponent second. Then I'm going to look at that, and I have no multiplications or divisions at all, so I can skip to step number 3. And all I'm left with is a bunch of addition. So if you want to do that addition all at the same time, that's perfectly okay. 1 plus 3 is 4. 4 plus 9 is 13. And now let's see, can we do this division? So 13 thirds. 13 and 3 are both prime numbers, so we cannot simplify this fraction. So that would be my final answer, 13 thirds. All right, example number 4. This example I like because it has a lot of grouping symbols. Okay, when you have multiple groupings, you need to start from the inside and work your way out. So if you can see, the innermost grouping symbols are these round parentheses right there. So I'm going to start with that. Okay, inside those grouping symbols, we have a multiplication and an addition, and we know multiplication comes first. So 2 times 3 is 6, so this is 6 plus 1, which is 7. So I'm going to rewrite the problem. And inside those parentheses is now going to be a 7. All right, at this point, the parentheses no longer mean grouping. We've already taken care of the grouping by simplifying everything inside there. The parentheses now mean multiply. So now we have 5 times 7. So some people don't even like to write the parentheses. They just put a multiplication symbol. I keep them there just because I know that parentheses can mean lots of different things. So now I have to work inside these grouping symbols. Okay, now I'm going to focus on just inside the square ones. So inside the square ones, again, I have this multiplication. 5 times 7 is 35, and 35 minus 10 is 25. So I'm going to rewrite the problem now that I have simplified inside those square parentheses. So again, now these square brackets, they mean multiply now. They no longer mean grouping because we've done all that simplification inside. So I got to do this. I need to do this multiplication right here. 2 times 25 is 50. So 1 plus 50 is what I'm left with, and 1 plus 50 is 51. So there is my final answer. So these can be a little confusing, so make sure that you always start from the inside grouping symbols and work your way out. All right, another example that has a fraction bar in it. All right, so again, you have to decide where would you like to begin. Do you want to start in the numerator or the denominator? It does not matter. This one, I think I'll start in the numerator. Okay, so let's see this. I have 6 divided by 3 times 2. So the first thing I see is a division. Again, remember you go from left to right. It's all multiplication or division, so we're going to go from left to right. 6 divided by 3 is 2, and 2 times 2 is 4. All right, so there I have completed my numerator. Now let's look at my denominator. In my denominator, I see that I have a power. So 3 squared is 9, and 9 minus 1 is 8. So I have simplified my numerator and my denominator separately. Now we're going to do that division. Can we simplify 4/8? Yes, we can. They both have a factor of 4. So this is 1 times 4, and 8 is 2 times 4. The 4's will divide out, and I am left with an answer of 1/2. So again, make sure that you're using all the proper methods that we talked about when we talked about fractions as well. All right, this is probably the worst kind of example that you could get because it's an order of operations problem and it has fractions. So a problem like this is really going to test if you really have all those skills from the fractions section down and you know order of operations at the same time. So again, we're going to start with order of operations. First step is grouping symbols. We do have some parentheses, but if you'll notice, these parentheses are just holding that 3/8. So it's not really a grouping symbol. It's just telling us what the base is for our exponent. So we are going to do this first. Okay, 3/8 squared. This is 3/8 times 3/8, and hopefully everyone knows that that is 9/64. So I'm going to replace that and rewrite my problem. All right, and then I'm going to look for any multiplications or divisions from left to right. So from the left to the right, the first multiplication or division I see is right here. And from our fractions, we know multiply your numerators. We can't do any simplifying here, so we're just going to multiply our numerators and multiply our denominators. So we get 9 over 64 plus 1/4. And then when I multiply here, I get 3/16. All right, and if you look, all we have left are addition problems. The problem is we do not have a least common denominator. The good news is that all of these are all multiples of 64. So we can know that 64 is going to be our least common denominator. So we know that we need to change all of these to a 64. Okay, 64 here is already there, so we don't have to change that first one at all. 4 times 16 would give me 64, so I have to do 1 times 16. And then 16 times 4 is 64, so the 3 times the 4. Okay, so there are all of our equivalent fractions with a common denominator. And then we are going to keep our denominator, and we're now going to add together all of our numerators. So 9 plus 16 plus 12. Helps if I learn how to use my calculator. All right, is 37. And 37 is a prime number. It does not go into 64, so that would be my final answer, 37/64. So this is kind of the worst problem that you could see because it involves everything from fractions and everything from order of operations. So if you can do a problem like this, then you're really good with your fractions and you're really good with order of operations and you are ready to go. All right, objective number 2 in this section talks about evaluating algebraic expressions. And if you don't know what those words mean, you have no idea what they're asking you to do. So it's really important that we know what these mean. So let's talk about some vocabulary first. All right, in algebra, a variable means that we're using letters to represent numbers that we don't know. So if you have a variable expression, that means that you have an x or a y or some kind of variable in there. Okay, we're going to have a letter. An algebraic expression is a collection of numbers. Could be numbers and variables. It could be operators. There could be add, subtract, multiply, divide. It could be grouping symbols. It could be exponents. Okay, anything goes. Okay, but there's going to be no equal sign, and that's the important thing. Expressions, there should be no equal sign. Okay, so it's just going to be add, subtract, multiply, divide. Maybe some powers, maybe some parentheses, but no equal signs. If you evaluate an expression, okay, you need to do 2 things. The first thing you need to do is replace the variables with whatever numbers they tell you, and they will tell you exactly what each of those variables stand for. And after that, then you will need to find the value of the expression. What that means is simplify using order of operations. Okay, so 2 steps. Replace all the variables with numbers, and then use order of operations to simplify and get one answer at the end. All right, so we'll start with the simple one. Okay, we want to evaluate when z is equal to -3, and here is my expression. So the first thing I do is I take this expression, and every place I see a variable, I'm going to replace it with a set of parentheses. This is called a skeleton. So instead of the z, I put a set of parentheses. So 7 plus 3 times parentheses. I don't know. Okay, and now we are going to replace this z. The z we know is -3. So inside those parentheses, I'm going to put a -3. So we now have a numerical expression. So above we had a variable expression because there was a letter. And now that we've replaced that variable with a value, we now have a numerical expression. And this numerical expression we can simplify using order of operations. So we have 7 plus, okay, 3 times -3 is a -9. 7 plus -9. Now the next 3 sections we're going to talk about dealing with negative numbers. For now, just think of it as money. If you have $7 and you owe me $9, that means you still owe me $2. We will talk about the specific rules for working with those in later sections. All right, here are some more expressions. So if you feel like you know what you're doing, go ahead and press pause and try these on your own. So the first thing I'm going to do is I'm going to replace that y with a set of parentheses. So 3 parentheses squared. Okay, what is the y? If you look up here, y is -4. So a -4 is going to go right here. Remember, when you do order of operations, you have to do those exponents first. So we have to do -4 squared. -4 times -4 is +16. So this is 3 times 16. And 3 times 16 is 48. So there is my final answer. All right, B, same thing. We're going to take that variable expression, take all the variables out, replace them with parentheses. So y is -4, so -4 goes in here, and x is -1, so -1 goes inside there. The first thing I'm going to do is clean this up a little bit. Say we have subtracting and -1. Subtracting a negative is the same as adding, so this is actually 2 times -4 plus 1. So I'm going to clean that up a little bit, and then 2 times -4 is -8. -8 plus 1, again, if you owe me $8 and you only have $1, you still owe me $7. So that is how we evaluate expressions. All right, objective number 3 in this section is just to determine whether a number is a solution of an equation. And I'll explain, let's talk about some more vocabulary so I can explain what that means. All right, when you are working with equations, that means you're going to have two expressions that are equal to each other. So you are going to have an equal sign in there, and that's what makes an equation. An equation is that equal sign. In chapter 2, we are going to do nothing but work on solving. So chapter 2, you're going to see solving equations. That's all we're going to do. But for now, we're just going to focus on the equation, so the solution of that equation. So if you have a solution for an equation, that means if you plug it into the original problem, so if you take that solution, you plug it back in, it should work. It should give you a true statement. Okay, so we are going to focus right now on just checking the answers, and that's another way we can use order of operations is to help us check answers. All right, so we want you to determine if -7 is a solution of x plus 23 equals -16. So this is the original equation. Okay, let's say that we have solved it and we think the answer is -7. So we just want to check to see, is that true? So we are going to take this equation, and every place you see an x, I'm going to replace it with a -7. So x plus 23 equals -16. Is this true? If I owe $7 and I have 23 in my pocket, that means I have $16. Okay, so the question is having $16 the same as owing? Okay, that is not the same thing. That is a false statement. So if we get a false statement when we plug in our solution, that means we have the wrong answer. -7 can't possibly be the answer. So -7 is not a solution. If I plug it in and it works and I get a true statement, then that means it would be a solution. But in this case, we got a false statement. So the -7 could not be the solution. All right, here's another example. Same thing. Determine whether 6 is a solution of 3x minus 10 equals 8. So start with your equation. Every place you see an x, you're going to replace it with parentheses and then put that 6 inside those parentheses. So is 3 times 6 minus 10 equal to 8? So again, order of operations tells us that we do that multiplication first. So 3 times 6 is 18. And 18 minus 10 is 8. So this is good. We do have, they are the same. The expression on the left and the expression on the right are the same. This is a true statement. So that means 6 is a solution. So again, this is just the checking process that we're going to need to do in the next chapter. So it's really important that we are familiar with those order of operations so that when we get to chapter 2, we can check our equations. All right, and the last objective in here has to do with translation. Now there's a lot of translation. You did a little bit of translation back in section 1, in section 2, but we're going to do a little bit more now again because in chapter 2 we're going to do a lot of translation. So it's just trying to get us ready for that. So let's talk about how we translate these phrases into expressions and how we take sentences, full sentences in English, and change them into math. All right, so there is a chart in your textbook that helps just keywords that will help you translate. So this first column tells you a bunch of different words that could mean addition. Okay, sum means addition, plus means addition, added to. Be careful with that one. More than, increased by, be really careful. English is a very specific language, so we'll talk about some of those little tiny hiccups that could happen. So just be careful with the words, because remember, words do have meaning. You can't be just willy-nilly. Okay, you got to make sure that you are translating word for word in the right structure and everything. Okay, so then each of these columns, so all these words could mean subtraction. Multiplication, okay, twice is a good word. Twice means to multiply by 2. Okay, it's very specific. Twice means to multiply by 2. There is a word that means to multiply by 3, and if you've never heard it, the word is thrice. T-H-R-I-C-E, thrice. I like that word. Okay, all of these could mean division, quotient, divide, okay, ratio, all those, okay. And then equals, equals is the verb. So if you have a verb, you have a full sentence, right? You got a noun and a verb. If you have a verb, that means there's going to be an equation of some sort. So anytime you see a verb, you should automatically be thinking it's got to be an equal sign or something similar. So example 8, here we go. Make sure that you read the instructions. Write an algebraic expression that represents each phrase. Right, and they tell you, let the variable x represent the unknown. So I don't want to see any n's, I don't want to see any other, I want to see an x because the directions specifically said to use an x. All right, so if we read, the first thing I see is the word product. Product means to multiply. So I'm going to put a little multiplication symbol up here. Okay, we are multiplying. And what are we multiplying? We are multiplying 5 and a number. And that number we know we should represent as x. We don't know what it is. That's our unknown. So how do I write 5 times x? Okay, 5 multiplied by x. There's a lot of ways. You could do 5 times x. You could use parentheses, 5 times x. But the easiest way is to just do 5x. In algebra, it's just understood that if you have a number with a variable right next to it, that multiplication is the operator happening between those two things. All right, B, a number added to 7. Well, first of all, I don't know what the number is, so I'm going to call it x. Okay, added to. So we know that addition's going on here, but you have to be really careful with this. Added to or subtracted from. Okay, these are two phrases that you kind of have to be careful with. Because you have a number and you are adding it to 7. 7 already exists. 7 is what you have right now. Okay, so you should start with 7 and you are adding to it a number. Okay, so 7 plus x. You should be really careful with this specifically because if this said subtracted from, so let's just say that this said subtracted from, okay? So a number is being subtracted from 7, means you're starting with the 7 and you are subtracting from that number. Okay, subtracting from that x, from that 7, a number that we don't know. So just be really careful with, I know that the English language especially is a little bit confusing because the way that the words are put together makes a big difference. So just be really careful when you work with these. Okay. A number, okay, again, we're starting with a number, x, divided by. Divided means exactly what you think. It means divided by 11.2. And this one we can just go from left to right and it translates exact. Okay, so and there's lots of different ways to write division. Personally, I think the easiest way is just to write a fraction bar. You could write x with the division symbol 11.2. Okay, that's fine too, but I just think the fraction bar is probably the easiest way. All right, and D, I like this as an example because it really talks about the importance of a comma in the English language. Okay, a comma means to pause, and that pause is really going to help you. So twice, hopefully everybody remembers the word that twice means to multiply by 2. So what are we multiplying by 2? We are multiplying a number. So first, and then we're going to pause. Okay, so this all is one phrase. So 2x, pause, and then plus 1. Plus means to add, right? So plus 1. So that comma is really important. It kind of tells us like when to stop and kind of regroup it and then move on. All right, last example, here we go. Okay, so this time it says write each sentence as an equation. Okay, that gives you a big hint right there. Equation means I need to see an equal sign, so that means I'm looking for a verb. And then it also says to let x represent the unknown. So again, that's the only variable I should see is the x. Okay, so I'm going to look at this first sentence. The quotient of 15 and a number is 4. Okay, is. There's my verb right there. So that's where my equal sign goes. Is 4. So I already have the right side of my equation already done. So now I'm just going to focus on the left-hand side. Okay, this says the quotient. Quotient means there's a division problem. So I'm going to put a fraction bar because that's my favorite way to write a division problem. And what am I dividing? I am dividing 15 and a number. And remember, a number is x. So 15 and x. The nice thing about quotients is they always give it to you in order, numerator and denominator. All right, B, same thing. Okay, first thing we're going to look for is that verb. And we do have a verb, is. Okay, so is 99. So you've already got the whole right side of the equation done. Now let's work on the left. 1 less than twice a number. A lot of people have a hard time translating this. I'm going to flower up the language just a little bit to try and give you some context, because sometimes having a little bit of context can really help. If I tell you that you're going to make $1 less than twice my salary, what's the first thing you want to know, right? How much I make, right? You want to know my salary, because I'm going to take twice my salary, which is X. I don't know. You guys don't know what it is, and I'm not going to tell you. So I'm going to take twice my salary, and then I'm going to take $1 less, and that's going to be what you get paid. So notice how the order of the words doesn't always match the order that you're going to write the math in. So be really careful with English. It can be a very frustrating language sometimes. All right, so that is the end of section 4. Please go ahead and go watch some more videos, get started on the homework, and in sections 5, 6, and 7, we're going to talk about how do we work with those positive and negative numbers that we talked about earlier in this section. I'll see you then.